In this video, I'm going to continue working on the practice questions for grade 9 ASP for the focused IPQs. This is for the term 2 exam. This is now moving on to the law of conservation of energy. Conservation of energy simply states that energy cannot be created or destroyed. It can only be transferred. So if I have potential energy and I start to move, I can convert that into kinetic energy. If I had 100 joules of potential energy, it will become 100 joules of kinetic energy. It transferred. Sometimes energy gets transferred the wrong way. It becomes heat or it becomes sound or something. Maybe I will lose 10 joules over here, converted into heat. That means I have actually lost some energy. I will have maybe 90 remaining. So in this case, I would have only 90 joules. I didn't destroy 10 joules, no. I lost it to heat, a different type of energy. In total, the total energy remains the same. The total energy will be 100. If I had 100 to begin with, I will have 100 at the end. It could be 100 gone from here, it could be whatever, all of it could be 100, it doesn't matter. This is the idea of the conservation of energy. It is transferred, it is never destroyed or created. So the answer obviously would be B in this case. I missed B with a circle, terrible. Anyway, continuing on, now we're trying to find the maximum gravitational potential energy. That is to do with the height. Gravitational potential energy is related to the mass times the gravity, of course, times the height, right there. Bigger height means you have more potential energy. That means A has the highest height, is higher than D. I would pick A. Then it would be D, then C, then B. That's the ranking, highest to lowest. The kinetic energy is highest at which point? So we'd assume that the kinetic energy is quite low here. He might not be moving that fast. He might be, but it's not important. It'll be more as he goes down, because as he goes down, he converts that. Because gravity is pulling it down, it's accelerating. It's getting faster and faster. At the highest point he will have is going to be B. That will be the kinetic energy highest at B. It will reduce a little. Fun fact, if I started at A and I pushed and the ball fell down, it will never go past A. It would go down, it'll go up, and it'll come back down again. It will never be able to go beyond that height. If I started at this height, I cannot go beyond that height. That's the maximum height I can do because that's the maximum energy. Just assuming he had 100 joules over here, what would happen is that 100 joules will become kinetic energy underneath 100 joules. You can use the kinetic energy formula. As you know, kinetic energy doesn't depend on the height, but it depends on a half the mass times the speed squared. And that's quite a lot. So that means it will be highest. It will reduce back to 100, the highest point again he can reach. Once he's used up his 100 joules, that's the highest. And there we go. He cannot do any more. We'll need like an engine or something to make him continue onwards. Okay, very nice. So we've answered these two. And here a car travels at a constant speed up a hill as shown in this diagram. So what's happening to his gravitational potential energy and his kinetic energy as he goes from A to B? Well, first of all, the clue here, it says constant speed. As he's going up, you would normally expect it to slow down, like we did in projectile motion previously. You know, the ball goes up, slows down, stops, and comes down. But no, this is a car. He has an engine. He's continuing at a constant speed. So first thing I know is that this is wrong and this is wrong. It will be staying the same. So A is out, C is out. We have two choices now. As he's getting higher, you can clearly see that the height is increasing, which means the potential energy will increase. In this case, the answer must be B. Potential energy will increase, the kinetic energy remains the same, only because it told me it is traveling at a constant speed. If it wasn't, then you could say it will decrease. As it goes up, he'll slow down, stop, and he'll return back again. But this is the clue there for that question. Now, in this one here, we have a ball, we have a mass, we need to find the maximum speed as it swings back and forth. So the idea here in this question, we have a height here from the ground. This is the PE, this is the maximum potential energy. As he goes down, it will convert to kinetic energy. That will be the maximum kinetic energy down here. Now, I might not have a speed, I might not have the energy, but we can figure it out. Using the law of conservation of energy is the total energy before said that 3 times. The total energy after. Before equals after. After. This is the idea. I want to show you a shortcut, by the way, after this. This is just the main way, and I want to show you the shortcut. In this case, we have at the beginning, we have potential energy, and we can say that the speed here is 0. As it goes up to here, the speed will drop and become 0 again, and it will come back down. So at the top, we have a potential energy, but we don't have kinetic energy. You can write plus KE. I'm just going to show you step by step. This is the initial. Okay. At the end, you have the kinetic energy, and the potential energy will be 0. We're going to get to that in a second. This is the general rule, KE. Now, we've agreed, like I said, 0 speed at the top, so I don't have any kinetic energy. It will be P only. Potential energy, gravitational potential energy. At the bottom, the height would be 0. The difference here, you can see that this is going to be 0 at the lowest point. So I have no potential energy. That becomes 0. So that is KE. Now what I can do is I can do a little bit of math. mgh equals a half mv squared. Now, we have the mass in this case, but actually, look, everybody brought mass to the party. We don't need mass. They cancel each other out. So you wouldn't even need it. You can write it, by the way. You can solve it. You can do shift solve. Right here, you can do shift solve and get v if you wanted to. But I'm going to rearrange and make it look a bit nicer. What I'm going to do now is I want to isolate v. I take this across to the other side. And by the way, I'm going to show you the shortcut on this side here, I promise you. So if you don't follow this, don't worry. I'll tell you what you can do instead. This becomes 2gh equals v squared. I want to cancel the squares, so I take the square root on both sides. V will be the square root of 2gh. By doing this, you can directly substitute the values for the height in this. The only thing you needed to know in this case was just the height. You didn't need anything else to find the speed. That leads me to my shortcut. My shortcut is this formula right here. This will always become this if there's only potential at the beginning and only kinetic at the end, and they swap. This will work. It won't work if it has a speed and potential at the beginning, then you won't be able to do that. You have to add them and do the long way. But most examples that we're going to do in grade 9 is just this. So you can literally just do v equals square root of 2gh if you ever get asked to find the speed and you have a height. We have a height. I want to find the speed. Let's try it right now. Square root of 2 times 9.8 multiplied by 2.5. Sticking this into my calculator, I will get, let's check, 7. Directly, I will get 7. So this is the concept that you're supposed to know. This is the shortcut just to get the final answer. It won't be on your exam, your, what's it called? The formula sheet. So you might want to write that down or memorize it just before going into the exam. As soon as you give you the paper, quickly write it out. Square root 2gh. Just write it down so you don't forget, and then you can continue the exam. That's a little exam tip there for you. So, square root 2gh. Very nice. Over here, boy drops the stone on this rock, and look at this. It's asking for kinetic energy, then it's asking for the stone's speed. Maybe we can go ahead and try the same thing. Let's see. Where am I? What am I doing? I can't remember. Well, we don't need to in this case because you'll have calculated the kinetic energy. Let's do it. So, the problem now is we started with the height, and then we have another height. So there's 2 heights. So the total will be the difference of the 2 heights. The general idea is the energy before equals the energy after. Now, the issue is I did have a potential energy at the top. The starting speed was 0. I need to find the kinetic energy at the end, so I will write PE. I'm supposed to write plus KE, but there's no kinetic energy at the beginning, so it's PE. As it's falling, this ball, as it's falling, reaching the second point, he now has a speed. He has a KE, but he's still not on the floor. The floor is here. So he has a KE and he has a PE, potential energy and kinetic energy. At the top, as he was holding it, he would only have potential energy. This is not a ball, this is a person with a hand now. Why did I draw a person looking like a ball? If I was to draw a person, don't laugh at my drawing, please. He's a skinny person. This is his legs. And he is holding the ball in his big hand. 1, 2, 3, 4, 5 fingers. He is holding the ball and he will drop the ball. So that's what he is doing. He is going to drop this ball. And there he is. Okay, No kinetic energy at the beginning. Once it's released, he will have potential energy because it's still not hit the ground. This is the ground. And he's floating for some reason. Let's give him a stool to stand on. There you go. He's standing on a stool. Okay, being very silly. And then, of course, it falls. Good. What am I saying? Afterwards, he has a PE and he has a KE. He has both. Okay. So this is initial. This could be final and final. No problem. So in this case, I need to find this. I will make it a little bit nicer. Let's take that to the other side and subtract it. Let's do the PE initial is minus PE final, and then I can get my kinetic energy. So all I do is find the two heights, subtract their answers, and you'll get your energy. So let's go ahead and do that. I'm going to take this, I'll bring it over here, I have some space. At the start, there's MGH, right? So MGH minus MGH. This is the first height, this is the second height. You realize that I'm only subtracting the heights. I'm going to write the whole thing just to keep it simple. 0.5, that's the mass, M, multiply by 9.8, multiply by the starting height, which was 5.5, minus, I'll keep that separate just so you can see what I'm doing, that's separate, minus the second height. Mg is a common factor, by the way. You can take it out and just subtract the heights, but I'm just not going to make it too complex for you. Let's keep it simple. M, same M, 0.5, multiply by the same gravity, 9.8, multiply that by the new height, 2.5, 2.5. Put that into my calculator. I will get my final answer. If I was to do this, I should get around 14.6. 14.6 joules. So that's all I did. I calculated the potential energies and I subtracted the two. You could, like I said, do mg h minus h if you wanted to. Whatever. As long as you get this answer, I am happy. Next, I need to find the speed. So I've just calculated the kinetic energy. I can use it to find the speed now. So I have the kinetic energy formula, Ke equals a half mv squared. I wrote that wrong. mv squared. This is the rule. Shift solve will get me the answer, or I can rearrange the formula. I'll rearrange. Half, take it to the side, becomes 2 Ke equals the m. I'm going to now cancel the m. I'll divide both sides by m equals to v. I don't want the square. I'll take the square root. Like I said, you can do shift solve. The only problem with doing shift solve in this is because you have a square, it's a bit slow. The calculator lags a little. You'll get the answer, but it's a little bit slow. Anyway, 2 times 14.6, divide that all by the mass, which we already have, was 0.5, and I solve this, and hopefully I will get around, what do I get? 7.6. According to this, let's check. Square root of, doesn't sound right, 14.6 divided by 0.5. 7.6, yes, this is right. Joules. Don't forget the unit. 7.6 joules. Not joules, I am wrong. It's terrible. How can I do this? Why did I make such a big space? Let's do that again, 7.6. This is a speed, meters per second. You get 1 mark for the units, so please be careful. Don't mess up the units like I just did. All right, joules, meters per second. Now, in this case, the bob has a mass, started from position A as a height, very nice, massless. Find the mechanical energy at position A. Mechanical energy means the total energy, kinetic and potential. Just like I said before, at the highest point, he will not have any speed. It will slow down, stop, and change direction. So at this point, he has PE. PE only, maximum. At the bottom, he will have KE maximum. Okay, so let's go ahead and solve this. In this case, I will need to find the PE only, potential energy only. I will do mgh. The kinetic energy here is 0. mgh, that is 2 times 9.8 times the height. 30, not good. I don't want it in centimeters, I want it in meters. I will have to divide 30 centimeters into meters, by the way, just so you know. You just simply divide by 100. And that becomes 0.30. You move the decimal point 2 times. 0.30. I'll write 0.3. And putting that into your calculator, you will get the energy, the highest energy at the beginning, is about 5.88 joules. 5.88 joules. Find the speed at position B at the ground level. I can use my little trick now, can't I? I can go ahead and use my trick. I don't need to know the maths. I can just use the thing that I wrote earlier. V is the square root of 2GH. Putting this into my calculator, let's see. Square root of 2 times 9.8 times the height. We had the height. What is the height? 30 centimeters, 0.3. Sticking this into your calculator, you will get 2.4 meters per second. I wrote that terribly. I'll try that one more time. Putting that into the calculator, you will get 2.4 meters per second. That is the speed. And that's all you had to do. You don't have to do the whole fancy adding the formulas, cancelling the m's, rearranging. No, directly use this rule. Very good. What is the mechanical energy at position C? The mechanical energy at position C, well, we've just said, we've calculated it already, right? The total energy remains the same. 5.88 will be here, potential. That 5.88 becomes kinetic, and that will become potential again. I will have the same energy. I have got frictionless. There is negligible air resistance, so I don't lose any energy. Directly, it will be 5.88 joules. And that's the last question. Thank you.